the conference. I'm glad to introduce Anand Murthy Raj sir. He's a well-renowned name in the world of agile. Actually, he's Asia's first SAFE fellow and SPCT. He has got more than 25 years of industrial experience, in which like 15 years into SAFE and agile consulting, coaching, and training. He's a founder director of Gladwell Academy. He's a keynote speaker in many world-renowned conferences. His expertise are into business coaching, agile transformations, consulting, strategic initiatives, and developing organizational growth strategies. I believe all people are here will learn more from this particular session, and you add more value to your kitty. Thank you, sir, for being here. Stage is yours, sir. Please go ahead.
Thank you. Thank you very much for the introduction. I hope my voice is clear.
Yes.
Yes, sir.
Okay. So I'm not going to talk something that you don't know, but I thought some fundamentals are required for us to understand. For the next 30-40 minutes, I'll try to talk something about a very interesting concept called neural networks. Right? First, let's understand what is artificial intelligence. According to Google, AI is a field of science concerned with building computers and machines that can reason, learn, and act in such a way that would normally require human intelligence. Right? And it involves a lot of data. And AI is a broad field that encompasses many different disciplines, including computer science, data analytics, statistics, hardware, software, linguistics, neuroscience, and even philosophy and psychology. On an operational level of business use, AI is a set of technologies that are primarily on machine learning and something called deep learning, and used for data analytics, predictions, forecasting, categorization, natural language processing, recommendation, etc. So essentially, in one line, if I have to put, artificial intelligence is all about teaching machine how to behave properly. That's it. It's about the ability of the machine to learn. Let's look at a little bit of a hierarchy here. The outermost layer is all about data. If you don't have data, forget AI. Then you have a concept called artificial intelligence. Then you have something called machine learning, ability of a computer to learn itself through some sort of an algorithms. Then you have deep learning. In deep learning, you have something called neural networks. So wherever the word neural, I'm going to talk about that in a few slides from now, but the word neural should immediately remind you of a word called neuron. It's a network of neurons, which essentially is the human brain. And we are trying to mimic how human brain works. The only difference between a machine and a human is we have emotions and machines do not have emotions. And the day machines become sentient, that's it. We have lost the game in this world. If you look at this picture, this is a small piece of a human brain that has been created by Google on multiple experiments that they had done. Right? Just look at this network. It is such a complicated network. Right? And isn't this an amazing network as well? You really do not know from where what is going. It's a jungle of wires that have been connected, and everything passes through electrical signals within the brain. And what we are trying to do is trying to copy this on a machine. When I first read this article, I was kind of amazed looking at the way how it works. So my interest towards neural networks started, and I eventually searched a lot of videos, and I found one video that can help the concept of neural networks so easily that everybody today in this conference will get something by end of today. So let us get started to understand what is this story of neural network all about. Can somebody tell me what is this? Very simple. Everybody would say 3. Right? How do you know this is 3? We do not write 3 like this. We write it in a more structured way. But how did our brain analyze that this image that I am giving you is actually 3? Right? It's a very sloppy written image, and it is rendered in a very low resolution of 28 by 28 pixels. But our human brain has an ability to recognize patterns. And through patterns, it was able to tell this is a letter 3 here. Right? So in short, whatever happens in brain is all through pattern recognition. Let's take another example. So my brain, all our brains today in this conference did not have any problem to take this sloppy written number, which is very unclearly written number, and kind of put a picture like this in our brain, and we all said 3. We all said 3, correct? Now, I'm going to give you a series of numbers here. Now, if I ask you a question, what are all this? Immediately, all of you would say they are all 3. So our brain doesn't have any problem to recognize these sloppy written numbers and map it to a character 3. But what you should understand is the art of Google Maps. When I gave this image, the route from this first image to the last image on the right-hand side is completely different from this image and this image. It's like 3 different routes, 3 different images, all going to the same destination called 3. In other words, the specific neurons that gets fired when you see the first image are very different from the specific neurons that gets fired when you see the second image and the third image. Imagine a Google map of 3 different starting points, all taking different routes, but eventually coming to the same number, which means something crazy happens in our crazy visual cortex of the brain that has the ability to render all these 3 images to a common result called 3. So something crazy happens in our brain. And what happens in our brain is the concept of neural networks. But it also tells us that 3 is not equal to 6, 3 is not equal to 5. It's not just about what is equal to 3. It also can interpret and tell they are not equal to 6 and they're not equal to 5. Isn't this again crazy? Isn't this again something super happening in our brain, which says that this is not 6, this is not 5, this is 3 only? So it is pattern recognition, but it also says, with the concept of pattern recognition, it says what is correct and what is not correct. Let's take this picture. Now let's go deep into the concept. If I draw this picture, the character 3, on a 28 by 28 pixel, this is how it looks like. Right? In a 28 by 28 grid, if I write this character 3, you will look, it comes like this. And some magic happens in the brain where this can be identified as one of these 10 numbers starting from 0 to 9. So imagine if you have to write an algorithm that takes any image as an input and gives us an output between a number between 0 and 9. It's so simple, isn't it? Take an image, make a guess. So simple. It is comically so trivial, but dauntingly complex algorithm to write. So if you have to run this algorithm on a machine, it's called machine learning. And the science behind this recognition is done through something called deep learning. In deep learning, we use something called neural networks to understand this. So what is machine learning and artificial intelligence here? As simple. Take an image, identify the result. That's it. That is AI. The whole concept of recognition is AI. So it's time for us to really understand how this happens. This is an example of a neural network. This is how our brains work. There are a lot of these circles. Each of this circle is called a neuron, and this circle connects to a lot of other networks inside. We call it as hidden network, we call it as internal network, till you hit some sort of a point here, and this recognizes the pattern and says, hey, this is a character 3 or a character 4. So this is not just about one or two networks. It can have a jungle of networks within it till you correctly hit a pattern. For example, today morning, just before coming to the conference, I saw a lion. The moment I see a lion, it can immediately recognize this, right? Imagine I saw one of you guys in a conference in 2019 or 2018. Now, if I see your image or see your face, it runs through multiple layers to actually identify you. But lion, it did not run through multiple layers because I'm able to recognize this pattern because it is pretty fresh in my brain. So really, I cannot tell you how many layers are there between by the time you actually recognize the pattern. Yeah. So there is series of pattern recognition that happens inside the brain. Finally, when it renders, what exactly is this number? Is it a number? Is it an animal? Is it some object? That determination takes through multiple networks. Right? So it's a very complex. It's not a simple 2 by 2 algorithm, or it's not a small multiplication and addition. It's a very complex algorithm. Now look at these networks. There are two networks that I'm showing here. One is called the idle network. If you look at the idle network, none of these neurons are actually firing, right? Firing electrical signals. They are just silent, or you can say that all neurons are sleeping. However, this is an active network where you can see some neurons are working or firing, or they're very excited, or some other neurons are not at all excited, and some neurons are slightly excited. Slightly excited. This is called an active network. The human brain can never go to ideal state. It will never go. Something or the other is happening in our brain. And if you decide that you should not think about anything, you are actually thinking that you are not thinking anything. Again, there is something activity happening in the brain. So the human brain can never enter into an ideal state as long as we are alive. Once we are dead, it goes to the ideal network state or idle network state. Now let's take this number. Now what I do is, I take this number. If you can observe this number here, across every pixel, if you see, how is it colored? There are some pixels outside the letter 7, which is completely black. There are some pixels that are very, very bright white in color. And there are some pixels that are slightly white in color. Then let's call it as grayish in color. So there are multiple tinges of this color here. Now, if I take this 28 by 28 grid, which is like 784 pixel grid, and if I draw it one below the other, and the color represents each one of them, that becomes your first input layer. That's your first input layer. So what is these colors? The colors represents the brightness of these colors here. And they actually represent, I'll show it in the subsequent images. And you go through multiple patterns. And finally, for example, I'm just taking four networks here, right? 4 layers here, sorry, 4 layers, one network. I'm just taking this fourth layer where it has 10 characters, 0 to 9, 10 neurons, 0 to 9, and our number represents one of these numbers. As simple as that. Right? But the way it works is extremely complex, but extremely interesting. Right? Same thing happens to 4. Again, I take an example of a 4, and then I have a 228 by 28 grid, which means there are 784 pixels. I put all the 784 pixels, something magic happens, and through the magic, in the layer number 4, which has about 10 characters, this maps to a character called 4, and now then the brain recognizes that this is a character 4. Right? But how does this happen is the beauty of what we need to learn. Right? Can you see some activation here? Right? There are some cells that have been active here. The other cells are completely dark. The dark cells are the one which are outside. So these are all neurons. The neurons which are not at all excited are the one outside the character 4, or which is written in black here. So they are not excited at all. They're not doing anything. They don't know what is happening. They're like as if you've closed your eyes and sitting in the dark. But some cells get activated in the first columns of the cells depending upon these characters, how they are, whatever they are, it gets excited. And the excitement, and suddenly, when I say excited means what? It suddenly starts glowing. And that glow is passed on to the next network. The glow is further passed on to the next network. And finally, you recognize the character 4. The propagation of this is what neural networks is all about. How do we propagate that information? Right? So step 1, some cells get activated in the first layer. Can you see the connection here? Can you see the connections here? It has got lot of connections, right? One to many connections. Second cell to many connections. So there is a one-to-one connection between every neuron in layer 1 to layer 2. There is a one-to-one connection. So if you have 784 lines here, you have 16 lines here. Now, why did I choose 16? I'll talk about that a bit later. But the excitement passes. So excitement passes. When you go through this second layer, you see not all of them are excited. Some of them are still saying, I don't understand what you're saying. Please forget it. But others say, well, I got it. I know what you're talking. Suddenly they get excited. The propagation continues to layer number 3. As you go from cell 1, layer 1 to layer 2, the number of neurons that get excited reduces. When you go to layer 3, the number of neurons that get excited still reduces. By the time you come to 4, you've got 1 neuron, and that says it is character 4. So that is how pattern recognition moves from layer to layer. But the interesting part is, how does it move? What is the logic? What is the logic of the movement? Right? So coming back to fundamentals, what is meant by neural? Neural is neurons. What is meant by network? How are they connected? You take a set of neurons, you learn how they are connected, you have learned neural networks. First of all, what is meant by a neuron? A neuron is a cell or a placeholder that holds a number between 0 and 1. Right? It holds some number. We'll see what is this number all about. But a neuron always has a number in it. And that number is between 0 and 1. For example, take this picture. Right? The moment I asked you, what is this? All of you would have said 9. And if somebody says 8, maybe they're sleepy today. They're very sleepy. Now, how do we get this number? Right? What is this number all about? So again, 28 by 28 pixels, 764 neurons are there. Now, if I zoom a part of this section here and look at this, you can see this neuron which is completely bright, completely white. They get the maximum value of 1.0. You see this neuron which is completely dark, right? It gets a value of either 0 or 0.01. It's not 100% pitch black. There's a slight white color in it, hence it is 0.01. And as the color goes towards the white, you can start seeing an increase in these values. So what does each neuron hold? It holds a number, and that number is called activation. That number is called activation. How do we define the number? Based on the brightness of the color. You define your numbers. So activation is a number that is always between 0 and 1, where white gives 1. I would call bright white gives 1, and anything in the black is 0. So it is only maximum, it is only between 0 and 1. Right? It is only between 0 and 1. I hope till here, all of you have kind of followed what I said. Right? Now, what I do is I take this grid, 28 by 28 grid, and stack it up one below the other. And now, depending upon the brightness of the color, these neurons will also become bright, will also possess an activation number along with it. It has an activation number along with it. Now, let's see what will happen. Now, I'm coming to the last layer. We'll talk about layers in between. This is the first layer. This is the last layer. The last layer obviously should have only 10 neurons, which is 0 to 9. It has only 10 neurons. Now, there are two more layers in between. We call them as hidden layers. Will it always be 2 layers? Not required. It can be infinite layers in between. When you see a character 9, maybe in some of your brains, you may have only one hidden layer. In some of our brains, it can be more than one hidden layer. So there is no proper idea between how many hidden layers you will get. We have chosen 16 neurons in these 2 layers. Now, why did I choose 16 neurons? Well, it's just a number that I like, and also it can fit on the screen. That's it. And why did I choose 2 layers? Well, you can have any number of layers. For the sake of this example, I choose 2 layers. I chose 2 layers. Right? So these are called hidden layers, and this is the final layer, and this is your input layer. So it is like this now. I give an input of this character to this system, to the algorithm. This algorithm first creates this layer, and then we start talking to the hidden layers. We start talking to the hidden layers. How do you talk from your first layer to the first hidden layer? Of course, between neurons, there are connections, there are paths, and that is exactly what you are seeing here. And it starts talking to the second layer. The second layer will talk to the third layer. The third layer will talk to the fourth layer. Eventually, you hit the nth layer when you actually recognize the final pattern, and that final pattern will have only one number, which is bright. All others will be black, which means this is character 9. That is how the propagation happens. Look at this. Now, activation of one layer determines activations in the next layers. Now, if you observe this layer here, some of them are bright, but one of them is still something like a gray. That means all these have an activation number of 1. This has an activation number of 0 or 0.1. This guy may have an activation number of 0.5. Again, even here, it is not 100% clear to us that this number is 9. We were not able to really identify in the first layer because there are so many layers with white in color, and there is one neuron which is gray in color. So it has to move to the activation to the next layer. That layer activation should happen. And this hidden layer, the first hidden layer, the moment it recognizes, these guys will get up and start shouting, "Hey, I recognize something." They become active. The moment they become active, they are connected to the next layer. Some neurons in the next layer becomes active. And they say, "Oh, I got what you said." These guys are saying, "Well, dude, I don't understand what you're saying. I'm sorry, I cannot recognize what you're trying to say, the pattern." So from one hidden layer, you propagate to the next hidden layer. And we keep on moving till we hit the last layer. So we keep on moving, right? The propagation keeps on moving, rigorously it moves. Finally, we hit the last layer, and this last layer clearly has recognized this number wrong, right? It is 9, but this layer says it is 7. So this path has been wrong, but confidently it says it looks to be 7 for me. How many times have you seen something that you see a picture which the person standing next to you cannot see? Or you see some picture, the same drawing, somebody else sees something in it, you will see something in it. And that is how 9 has become 7 here. Because this person, this network, when it saw, it is trying to recognize this 7 as, this character 9 as 7 here, which means this is wrong recognition. So the propagation has happened, but the final recognition, what you've done, says it is slightly on the wrong side. Now, we must have all heard about the disease called Alzheimer's. What is Alzheimer's? Alzheimer's is a disease when one network, one hidden layer cannot find anybody else to propagate. You cannot find anybody else to propagate. That means the activation in the first hidden layer does not trigger any neuron in the second layer. That means the propagation stopped at this point in time. That is when Patients with Alzheimer's looks at you. They've spoken to you 10 minutes back. They've asked your name. They've asked your age. They recognized you. After 10 minutes, they will ask you, who are you? Because the activation stopped here. Right? This is what happens to Alzheimer's patients. So the whole story should be, how is the first hidden layer influencing the next layer? And why must we have a layered structure? And what do you think the middle layers are doing? If we can answer these three questions, I think it will help us to propagate to the next level of understanding of neural networks. Now let's understand what happens in the middle layer. Take this character 9 here. This character 9 can be broken up into a circle and a line. Can be broken up into circle and a line. This is what happens in the hidden layers. We now break the image. We now break the image into smaller recognizable objects. For example, 9 is 0 plus a line. What about 8? It has the same vowel on the top, but it has another circle at the bottom. If you take 4, you have one straight line which represents this. There is another straight line which represents this. And there is a curve here. There is a horizontal line that connects this. So now you see one picture is broken up into number of smaller pictures. Right? This is exactly what happens in middle layers. Take an example of a circle. This circle can be broken up into 5 different elements that will make up this circle, or 5 different arcs can be created from one circle. It can be, when you add up all of them, you get this circle. You get this O or a 0 or a O, whatever it is. In spite of having so many years of experience, don't we get confused between 0 and O many times? We get confused. Right? That is why whenever we write 0, we put a line in it so that the other person should not get a doubt between 0 or 1. Same thing happens to the machine learning as well. Sometimes it will get a doubt. Right? Let's take these 4 numbers, 1, 4, 7. All the 4 numbers have one vertical line. And that vertical line can again be broken up into 3 small components. You can break it. Now, when I come here, these are all the elements in the second layer. So whenever they see the number here, now what is in the first layer? The first layer is this one, right? It's like this. Here, this is the first layer. Suddenly there is a vertical line. There are a set of neurons here who are white in color. So they represent some sort of a pattern. The moment you come to the next network here, these small patterns starts getting recognized here. So whichever neuron has these small patterns. So when I give an image of 0 to the first network, the second network will get activated when they see these kind of small patterns small arcs, small lines, they get excited. They get excited here. And they say, oh, I know who you are. I recognize you. Right? They get excited. What happens next? The propagates further. Now, these were all, when you add up all of this, you get these kind of numbers. So pixels to edges. So these are all called edges. They get activated. Now, how many colors are there? So many neurons get excited. Next, edges becomes patterns. This becomes a pattern. So when you add up all of this, you get a circle. And this is the guy who represents circle. And he says, hey, I got who you are. I am a circle. And that fellow gets excited. And all of these small other lines that we have written here, these 2 lines, they get added up. They become a straight line. And this guy below becomes a straight line. And the guy says, I can recognize this pattern. This is a straight line. So and this pattern, you have 2 objects. One is an oval and one is a circle. These 2 are now recognizing it. So here we moved from edges to patterns. And finally, patterns to images. And this image is 9. This is how the propagation happens through middle layers. Propagation happens through middle layers. Right? Now, let's take this image of this lion. The moment you see this lion, immediately, how did your brain say it is lion? One, you have seen lions many a times in TV. Few of you must have seen real lions as well. But actually, what happened in your brain was this. It started drawing the edges, and each of these edge was a hidden layer. And then as you started navigating, finally this image was kind of a similar image was rendered in the nth layer. And now that said, it is a lion. Just imagine how quickly it propagated. When I showed this image, immediately you said it is lion. Just see how complex the brain is, how fast it works, how fast the human brain has worked. Right from our eyes, which took the image, to continuously going. Now just pause for a minute and think about driverless cars. A car is being driven through all the patterns that it is seeing. It is recognizing the patterns. It is using a neural network. And now the brain, the car, as the machine understands that this is a straight road. There is no other vehicle. I can go. As you are driving, there is a signal. Immediately, the picture of the traffic signal is fed into the virtual cortex of the driver. The driver will realize it is a signal, and immediately the driver will see the color. The color is red. Immediately it recognizes red, and somewhere in the brain it says red means stop, and you will apply the brake. Imagine if the same thing has to be done by a driverless car. How much combinations of data, how much of data input that this machine should take to understand what is happening. Now imagine you are driving a car and there is an accident in front of you. Suddenly a vehicle which was going fast suddenly starts toppling. What will you do? Instantaneously you will apply the brake. How did that happen? That vehicle which was going, but if the vehicle did not topple, you will not apply the brake. You will still continue to drive. So what immediately happened was, then the vehicle toppled, that image was rendered to your visual cortex, your eyes. That eyes, that took the image of something that has fallen, and then it rendered into numerous hidden layers. And finally, it got into a recognition saying that this is an accident, you have to stop. And without thinking second whether the vehicle is coming behind or not, you apply the brake, irrespective of, you don't care what happens, you apply the brake, and action is taken based on the object that the machine understood. In this case, human is the machine, we understand. So just imagine how quickly it has to act, and what should be the power of these networks, what should be the power of computers that actually makes this happen. It has to be enormous, isn't it? Right? But all of this was great, but how do we do this? Right? How do we do this? What is the mathematical way to understand this? To understand this, we need to go back to the few slides before that I had said. What is a neuron? A neuron is a cell or a placeholder which has a number, and that number was called as activation. So every neuron here has a number, and every connection here has a cell, has a weightage. We call this as weightage. We call this as activation, right? So now W1 could be 2.07 because this guy sitting on the top was very bright white, and he said, well, I can understand this pattern. I know this guy very well, he said. So that guy connects to the next layer, and that connection could be of value 2.07. I'm just giving you some random numbers, right? Could be 2.07. The more clarity between this layer and this layer, this number slightly goes up. This number goes up. But if there is completely lack of clarity, maybe it will become negative as well. It can become negative as well. So there is weights and there are activation number. And if there is a connection between the first neuron to the second neuron, this gets an activation number of W1 plus A1. Right? This whole path is W1 plus A1. What about this W2 plus A2? It gets that as an activation number. So you multiply the weighted value to the activation number W1A1 or W2A2, similarly WNAN. In this case, W784 and A784. Right? I'm talking about for one destination neuron, there are 784 connections. Right? Imagine this number 7. And if you look at this 7, some part of this is very, very clear. It is bright green, which means I exactly know what it means. I can recognize the pattern very clearly is the meaning. As you go to the bottom and top, there are less clarity. I don't know what is it. It looks something like a number, but I don't know what is it. That's the feeling you are getting. So light green is a perfect match. The red is not perfect match. Somewhat it is a pattern. Right? It is a pattern. So this is what happens in your middle layer. So the one with bright white becomes bright. The one with bright green here or light green becomes bright white in your hidden layers. Others will actually take grayish color. They take the grayish color. But we decided that now when you do this algorithm and add all of them, right? That is for your second hidden layer. When you add them, these numbers can become huge numbers, right? They can become a huge numbers. They can be from -4 to +4, minus n to plus n. It can be any number in between the middle layer. But we all said that this number should be between 0 and 1 only. We said 0 and 1 only. That means we have to do something to this equation so that the value could be only between 0 and 1. Right? This is the activation number of this neuron. See, this is the activation number of this neuron, because this neuron can be connected through all 74 neurons. So when you add up this W1A1, W2A2, final that number will come here and sit as activation number. But when you add all these numbers, W1A1, W2A2, the number becomes any. It could be positive, it could be negative. There is no guarantee that it's going to be between 0 and 1. But our objective is to put it between 0 and 1 only. That means something we have to modify to this equation, which will make it between 0 and 1. And what we do is we add a bias to it. We call it as bias. Now, what is a bias? Bias is a number that we add here, which will more likely make the number between 0 and 1. But there is no guarantee still that the number between 0 and 1. It need not be. So we add something called a bias. In this case, if it is positive, the bias, what I put is 10. So if the answer is 14, let's say if our answer is 14, I put it as 13. If the answer is 100, I put the bias as 99. Which means by putting a meaningful bias, I'm able to push the value between 0 and 1. But I still cannot guarantee it, whether the value can come between 0 and 1. So what I do now is, we all know sinusoidal graph, correct? Cosine and sine. What is the minimum and maximum value of any sine value? It is -1 to +1. Sine 0 is 0, sine 90 is 1, sine 180 is -1. Similarly, cos 0 is 1, cos 180 is -1. And I'm not sure about those numbers. But any value of sine and cosine cannot be less than -1, cannot be greater than 1. It has to be between 0 and 1. That means you take an equation, you take any equation, if you put this output of this equation as an input to a sinusoidal graph, that means it will always rest between -1 and 0, 1. And this graph, this symbol what I put is called as sigmoid. Sigmoid is a function that will always be between 0 and 1, guaranteed. Hence, I take this number, I put a bias to it, and then I make this number as sigmoid function. With sigmoid function, I can 100% guarantee that the number here can only be between 0 and 1. If it is 1, it will be bright white in color. If it is 0, it will be black in color. In between, any other variation, accordingly, the brightness will change. So for every single cell that I put here, we put a bias and we introduce a sigmoid function. We introduce a sigmoid function to it. Now you have come to a point where you can tell what is the color of this network. Now let's see how complex it looks. Look at this. From 784, I have 16 plus one bias for each. Each one of them has a bias. So you have 784 into 16 weights, right? 784 into 16 weights plus 16 biases. Look at the complexity of the network. I have just taken a simplest possible example of 784 here and 16 here in the hidden layer. Our human brains has millions of neurons in every layer. Just imagine the complexity of the brain. And now if I take one step further to the second step, or if I take the complete step, it is 784 into 16 plus 16 into 16 plus 16 into 10 weights. Right? And there are 16 biases and 10 biases. Essentially, you have 42 biases and 13,002 weights and biases. If you add up everything, you get 13,002. These are like our knobs, our dials, right? These are our knobs and dials which you can tweak, and based on the tweaking, you will identify the right number here. I give an input, I take an output as 7. If I give 9, it is coming as 7. We have to tweak the network. We have to tweak these biases. We have to tweak the activation numbers so that it becomes 9 accordingly. Right? So there are so many options here. And who is going to tweak this? Who is going to tweak this? None of us are going to tweak. The tweak happens through machine learning. And eventually it starts recognizing the pattern consistently. Initially, it may be wrong. You will tell, no, it's not correct. It's 9. Then it says, how come I read it as 9? How come I read it as 7? It starts rethinking about it. And finally, it learns. So test data is absolutely important for us to train the neural network for pattern recognition. Right? Finally, how do I write a computer program or mathematically represent it? So you have different weights, W1, W2, W3 weights. These are all the weights that I put. I put all the weights in a row of a matrix. I put all the activations as a column of a matrix. When I multiply the two matrices, I get the equation of W1A1 plus W2A2 plus W3A3. Essentially, this is nothing but complex algorithm of matrix multiplication. That is how you can actually train the network, right? It's like this. Right? So weight of 0 to first, weight from the 0th neuron to the second neuron of your hidden layer, weight of the third neuron of the 0th layer it's like this, weight of the 0th layer to the first layer of hidden, second here, and you write all these in one row. You write all the activations of this in the other row. You get a product, and this is your final product, plus you add biases for it. So biases could be a network. So essentially, you see the multiplication of these two metrics, you get a product by adding the bias and then putting a sigmoid function to all of this. I forgot to show the sigmoid here, but putting the sigmoid function essentially leads to the next layer. Right? Next layer. This is as complicated as what I'm showing. And this is exactly what is the value of 16 digits. I'm just showing 9 here, but it has to be 16 digits here with a sigmoid function. When I get the activation for the second hidden layer. Similarly, I get the activation for the third hidden layer, fourth hidden layer, fifth hidden layer. And finally, we come to a point where we recognize the pattern and the brain says, here you go. This is character 9, character 7. This is essentially how it starts functioning. Just imagine how complex the human brain works. And we are trying to mimic the brain on a computer. What should be the capability and capacity of our computers? It has to be huge. Otherwise, you will not be able to drive an automated car. The car has to recognize patterns. The car is the mission. The car has to recognize patterns and take decisions accordingly. This is my final slide. I have a confession to make. Whatever I learned so far, I shared this is a part of this video. Right? I may be wrong with my limited information. I may be incorrect, right? Because this video may be wrong in the first place. Hence, I may be incorrect if the video is wrong. In case if you find something is wrong, please correct me, because it is not possible to learn AI in isolation. We all have to come together to learn how AI works. If you have any questions, I may not be able to answer today because I'm still learning. I'm a student for life. This is what I wanted to share today in this small opportunity that I got. If you have any questions, I would like to take.
Anand sir, Bala this side. So this is a great start to understand machine learning, neural networks and all. I think the basic start to get into ML models and how we developed LLM, right? So great insights.
I know it's too late for asking questions, but if there are questions, I'll try to answer. I may not have an answer, but I'll definitely try my best to give an answer.
After a long time, it's more of that maths and formulas, neural. It's some. I mean, one point of time, I felt like, where am I? But still, it's like it's so informative. Maybe it's taking a little more time for us to digest the thing. So, as you rightly mentioned, like you're a continuous learner. So we just started with the learning with this. But thank you so much.
Mission is also learning, huh?
Yeah, but thank you so much, sir, for the great insights. For me, I personally feel it's a good startup for me. Maybe now I'll start exploring more on this site.
Yeah, any open-ended questions, team? You can
Any
raise your
questions
hands.
from the participants?
Yeah. Well, we consider that there are no questions because there are no hands raised. I believe the topic needs a lot of brain.
Completely. Either all the participants are so clear that there are no questions, or it is
sir,
totally unclear.
To be frank, sir, you have touched upon multiple points which are, for us starters like us, it is completely new for us. Maybe few of them are experts who might be sitting in this call. But you deep dived into neurons and networks, middle layers, and pixel to edges, edges to patterns, and patterns to images. I just started writing, but I found a long notes. So probably we have to start somewhere, and I believe this is the day that everyone will start onto it. Yeah.
Okay.
Hi, Anand, Nagini here. I'm still lost in the presentation that there is no scope for asking any question now. But
it's a very complex topic.
Yeah,
it's a very complex topic. And until you spend a lot of time to understand this, you really cannot understand what is happening inside.
That's correct, exactly.
You cannot understand. So you'll have to take one step at a time, slowly understand, and then you'll really appreciate how the human brain works.
Right.
And then, as I told you, I was fascinated when I watched these videos to understand how neural networks actually work, and how deep learning uses neural networks to do pattern recognition. Just imagine voice recognition. Take South India. People from Karnataka talk a particular accent. People in Tamil Nadu talk a particular accent. People from Kerala talk a particular accent. But when you buy a Sony TV, press the remote and say, I want to hear videos from this guy, it still renders the same video.
Yeah.
Just imagine how much of training they would have given to these networks to really help us understand and render the right video, though our pronunciation is so different.
Right. But great opportunity to hear you again after a long time.
So which industry this research is going prominently, sir, as of today?
Every industry. Every industry.
Because
There is
you
no-
took example of Alzheimer's and all, right? So
Mm.
predominantly it's happening in health industry or it's across all?
Everywhere, everywhere.
Everywhere this is happening, but healthcare is pioneering this entire. So imagine there is a patient who is suffering from cancer, abdominal cancer. They take the patient, make the patient sleep on the bed. They rotate the bed by every 1 degree, right? So you will get, and they kind of change the orientation of the patient. They turn the patient like this, up and down like this, like this. So you get 1 million photographs of that patient's abdominal area. All the 1 million photographs are given as an input to an algorithm. The algorithm will take these 1 million photographs and then start checking to see what is the best angle the patient should sleep. So when you give radiotherapy, it doesn't affect other organs. Right? Or they take a patient, make the patient sleep, they take millions of photographs and then feed the photograph. And then the AI system can recognize patterns and say, okay, if the abdomen of a patient is like this, 10 years back, it was like this for somebody. Today, how is it? Did they develop cancer? And then it will say there is a 20% chance that this patient might get abdominal cancer in the next 10 years. So this is where healthcare is going. Healthcare is going. So
Any insights? Sorry,
huh?
please go ahead.
Now, there is a huge revolution that is happening in the market with the idea of AI, because we are able to process huge volumes of data in less time. Take pharma industry. Now, when you go to a doctor and take a medicine take an antibiotic medicine, the doctor gives different antibiotic medicine for different kinds of infection. How? Why is that one antibiotic doesn't work with everybody? Every antibiotic has a different set of chemical combinations, and these chemical combinations will work on that particular cell type of within the body. There is some cell called hand cell. There is something called leg. There is heart cells. There are lung cells. There are kidney cells. So it will work on that particular cell of that particular organ. Now, what is happening in pharma industry is it takes a lot of time to test which combination works for which organ cell type. With millions of data in the database, AI is reducing this time by 60%. Within 40% of the time, we will be able to get an antibiotic medicine to the market. So there is a lot of revolutions that are happening. At the same time, I also want to warn something that is happening in the AI space. AI can generate images, AI can generate text, AI can generate voice. If you combine all of these three, image, voice, and text, you can give one name to it called language. Right? Language is the operating system of human beings. We all survive because of a language that we can understand. If AI can create a language and start talking a language, I don't know what will happen. Maybe Arnab Goswami will be having meetings in his The Nation Wants to Know program, not with humans, but with bots. With bots. Right? Today, there is a research done in Forbes which says that the doctors do not have empathy for patients, because a doctor can only spend 1 minute, 6 seconds per patient per day on an average. But a bot can spend 1 hour with the patient. So patients prefer to talk to bots, not to doctors. Right? Mr. Lemon, who was working in Google, made an announcement once saying that his AI tool called Lambda has become sentient. That means it can understand human emotions. Right? He was fired. He was fired. I'm not talking about why he was fired. I am talking about what Lemon did. He risked his life, he risked his job to protect a computer. That means AI is developing what? It's developing close relationship with us now. It can be very dangerous. Can be very dangerous. So let's see where AI will take us.
No, I think we are hearing news, right? In few countries, people are utilizing this for the unethical purposes and all, and they're making it happen also.
Yesterday, there was a news that I saw. 60 countries, about 70 countries had come together to to sign an agreement saying that they will not use AI in any of the defense equipments.
Yeah.
There are 2 countries that did not sign out of those countries. One was China, which is the other?
Russia,
India.
India.
India didn't sign that. I don't know what is happening. Honestly, I don't know what is happening.
Yeah,
People are
even
worried.
in Global AI
Others
Summit,
sorry, go ahead.
yeah, even in Global AI Summit, which we attended recently, there has been a lot of discussions on this ethical AI. In fact, there was a ambassador who correlates these decisions among multiple countries, right? Even he was mentioning the same. Like most of the countries are not willing to implement AI within the government organizations or industries.
But I can guarantee you one industry that will get eradicated because of AI. One industry. Any guess which is that?
E-commerce.
Astrology.
Oh,
Because nobody will take the horoscope and go to the astrologer. Huh? You will upload your photo, you will upload the girl's photo, and you will ask Google, tell me, shall I marry the girl? And Google will tell, I've been following you from the last 20 years. I know what kind of a person you are. And it will tell, I know I've followed this girl also. I know what kind of a girl she is. And Google says, I will run an algorithm. Based on my algorithm, the person like you, person like her, when you get married, I see 70% that it will get divorced in 2 years. So Google will tell, don't marry her. Now the guy's face becomes so small, and Google will tell, I can still see your face now. If you don't agree to what I say, your face will become like this forever. The guy will say, no, I don't want to marry. See, astrology is gone. People will completely move away from any kind of human decisions. We all go to missions. We all use Google Maps every day to office, correct?
Yeah.
In spite of which we know the route, we'll still use Google Maps. Because we have become digital slaves to those systems.
You already use Google for everything, even for a headache also.
Yeah.
You go and type, what is this? I'm getting headache at 5 o'clock in the morning. And it gives you 100
Google will
symptoms
tell
and
you
you will
everything.
match all of them.
Dr. Google will give you all the data.
Yeah.
So
In even in recent IPL also they have introduced sentiment analyzer and what is the sentimental data which it is showing. So it is impacting.
if Chat
Any
GPT next version comes in, that's it. This current version is nothing in front of them. The next version of Chat GPT will create a revolution. And if people still believe that AI is a myth and all, I think they'll have to commit suicide. They don't have place in this world anymore.
any questions from the audience? Thanks, Anand sir. I'm just please raise your hand so that we can unmute you. All right. I don't see any hands raised. So thanks, Anand sir, for a great session. Even though offline we were thinking about what is this 1, 2, 3, 4 maths, algebra, and everything, but when it comes to the end, it created a lot of insight. Thanks so much for the great session. Thanks so much for
Because I know
all the hard work that you put.
it is a little difficult to understand, but I think once you start appreciating it, you'll start loving this concept.
Yeah.
Okay, guys, thank you very much then. Have a great evening, and we'll catch up again.
Sure, sir.
Okay.
Little token of appreciation. Subbu, you want to? You are on mute, Subbu.
Oh, I'm sorry. I hope my screen is visible to you all.
Coming up.
Oh, okay.
Yeah.
Yes, sir. This is a small token of appreciation from our side. Thank you for being here and sharing your insights. Thanks a lot.
Thank you very much.
Thank you so much. Thanks, sir.
I'll take
I
leave
think
then.
that's all for today, everyone. I hope you all had a great day today, getting into a lot of insights. Satish, you want to cover anything before we wrap up for the day?
Thanks everyone today. Thanks Anand sir, the panel speakers, everyone, the volunteers and participants. So tomorrow we will start at 5 p.m. and we have a lot of time for networking and one more round of panel discussion as well. So being a weekend, make sure we present and we can have the opportunity to turn on the cameras and have a interactive discussion as well. And make sure to bring your perspectives and experiences so that you can share with us, not just the speakers and the panelists. You as a participant also can share your learnings and experience of uses of AI in your current implementation perspective. And you can use the same link for tomorrow as well as a participant. And in case any of your friends or colleagues want to register who missed it, we have opened a day 2 registration. Feel free to share the information with your friends and colleagues.
Thank
Thank
you.
All right. Thanks, everyone. Have a
Bye.
great day.
Thanks,
Thank
Good
you all.
everyone.
night.
Good night.
Good night.
Thank you.
Good night.
Thank you all. Thank you. Bye.
Good night.
Thank you, everyone.